Okay, friends, welcome to the ORAN session. And good morning, good evening, and good night to everybody because most of the people are in different time zones. And so let's begin. So, this is the agenda of this session today. So, we'll talk about ORAN and all these articles or all these topics will be covered in this session. So, like evolution of RAN architecture, why we need OpenRAN overview, and these kind of things. I will try to cover all these topics in the next 2 hours or so, but if it is not covered, maybe I will take some other session. So all these topics I will try to cover in this session. So my friends, again, it's so good to see you all again. And this is Gaurav Goyal. First of all, thanks a lot for joining this training. So instead of spending time here and there, you are here. So this proves you are serious about yourself. This shows career growth means a lot to you. So again, I really appreciate from core of my heart for giving me your precious time. And I will try my best to make every second of your worth through this session. Again, this is me. My name is Gaurav Goyal, and I have been in telecom industry for over 17 years, mostly in the wireless industry. And I have worked in telecom in one capacity or the another. So I have worked for all the largest telecom service provider in the US like AT&T, Verizon, T-Mobile, Sprint, etc. And also with major vendors like Nokia, Ericsson, Huawei in the past, and worked with Infovista as well for a few years. And before coming to US, I worked in various countries like India, Nigeria, Japan, Finland, and UK also. So much of time has been spent in wireless networks only, right? So I have begun my career with 2G and now working with 5G for at least last 4 years. And at this moment, my main focus is on like 5G, Python, DAS, and ORAN. Okay, friends, this is all about me. And you can check my LinkedIn profile for more details about me. And these are my just iCards that I worked in these companies before. And before jumping topic, I want to say one thing that your involvement in the class is critical for you to benefit most from this webinar. So I request you, so if it is not absolute necessity, then please close your Outlook, social media, and like Facebook, any kind of these things, right? So that it will be very helpful to you because even a genius can't do two tasks at the same time. So it's my kind appeal to everybody. Please close all kind of social media or any kind of distraction, right? So are you with me? So please write yes in the chat box and then we can begin our session. Thank you. So these are the few list of abbreviations. So whenever I share this PDF, you can take that evolution. So the first topic is RAN evolution, right? So let's talk about RAN evolution. So to set up the stage, let's talk about RAN. Okay. So radio access network. So these are the commonly known as cell sites as well, right? You know it, right? Cell site. So these are the strategically placed to provide wireless coverage to users within a particular geographical area. You can see it all around. You can see it everywhere actually, right? The placement of RAN components such as cell site is critical to ensure that users have reliable and consistent access to network services they need, right? So when you are planning the deployment of radio access network operators consider various factors like they consider population density, topography, building density, and also traffic patterns within a coverage area. So by analyzing these factors, network operators can determine the optimal location and the configuration of RAN. And the main motive is to ensure maximum coverage and the capacity, right? Like for example, in urban areas with high population density and building density, right? So network operation may need to deploy more cell sites with lower output power to provide coverage to a smaller area. But in the rural areas, with lower population density, network operators may need to deploy fewer sites with higher output power to provide coverage to larger area. So placement of RAN also affects the overall network performance. So to provide seamless coverage and mobility, we need a strategy to place this radio access network components, right? You need to put a lots of cell site in different parts of the country to create a seamless coverage. Okay, so thousands of radio access elements create seamless coverage and mobility. So whenever you want to go from one place from Virginia to California, so you will need a seamless coverage and you will not make a drop call. Right? So wireless telecommunication system, right? So wireless telecom system components are composed of three main components. One is user terminal, one is RAN, and one is core net, right? So these are the user equipment. and mobile station in case of 2G. And other examples can be like smartphones, tablets, laptops, and any kind of wireless device. Then the user terminals are connected through RAN. So the RAN is responsible for providing connectivity required for mobile devices. So the radio access networks contains many things like antenna, right? It may contain RRU, it may contain BBU, right? So these are the three main elements of a RAN. So these are connected through air. So we are using a wireless connectivity, and we are using different set of frequencies, and we call it radio frequency. Okay. The radio access network is also connected to the core network with the help of backhaul. And the core network is responsible for various things like routing traffic between different networks, also provide services like voice calling, messaging, data service. And there are different means to connect RAN and core network. It can be fiber optic, it can be microwave. And if there is challenge in the terrain or large distance, then you are limited by curvature of the earth. Then you will use a satellite to connect RAN and the core network. So these are the main components of a wireless telecom system. So you have the user terminal, you have the RAN, and you have the core network. So now let's focus on the radio access network. So radio access network, so this is the part of the wireless telecom system that is nearest to the subscriber, right? And you can see it on the malls, you can see it on the mountains, rooftops, wall mounted on a building, right? So location is widely distributed, so you can see it everywhere. Since RAN creates seamless coverage and mobility, okay? So RAN is all around you, okay? So again, what is radio access network? So as you know, RAN has evolved from first generation to fifth generation, each generation improving upon the last, but essential component remains same. Like first one is antenna, right? So first one is antenna. So as you know, antenna converts electrical signal to radio waves and the vice versa. Then you have radio unit, and the function of radio unit is to use appropriate frequency bands and power levels. And then you have this BBU, which is baseband unit. And so BBU processes the signals. It contains software and hardware to do that, right? It makes wireless communication possible over the radio waves, right? So have you ever stopped to think about how your mobile device or cell phone is able to connect to the internet? How you are able to make calls and text while you're on the go, right? It's all thanks to radio access network that is all around you, okay? So next time you are out, take a look around you. So you will likely see cell towers and antennas on the top of a building, or along the roadside, or even in the mountains, beaches, provinces, right? So this type of antenna is inside the malls. So we call it in-building solutions, okay? So some people call it Wi-Fi access point, but this is not a Wi-Fi access point. It is an omnidirectional antenna, or sometimes an active antenna that belongs to radio access network, okay? And as you know that there are different names of RAN in different generations. So 2G is called GE-RAN, 3G is called UTRAN, and 4G is called EUTRAN, and 5G is called NG-RAN, new generation radio access network, right? Or next generation radio access network. So again, as I said, baseband. So baseband is typically located below the tower in a traditional network, and this is responsible for processing the baseband signals, and it is placed in the equipment room, and it is connected to the RRU with an optical fiber, right? So in the traditional network, BBU is in the same premises as in RRU. So then we have remote radio unit, and this is how remote radio unit look like. It is on the tower. So if you have not seen remote unit before, so it is on the tower and it looks like this, okay? So RRU is a radio transceiver that communicates with mobile devices over the airwaves, and it's located remotely, right? And then we have this CPRI, Common Public Radio Interface. So it enables the high-speed transmission of data over a fiber optic cable, right? So it allows the connection between RRU and the BBU, baseband unit. So this is the common public radio. So nowadays, it is not necessary that baseband is near the tower, and baseband can be centralized location as well. So CPRI is an interface that sends data from RRU to the baseband unit, and it is a serial interface which is very high speed connection. So basically, it is way to translate all those radio waves signal back to the computing function, which is done by BBU. As I said earlier, so this is our traditional RAN. In the traditional RAN, we have antennas and we have one box or one case where we have BBU and RRU together. And antennas and BBU and RRU are connected with the help of RF cable. But in the contemporary RAN, we have RRU on the top of the tower near the antenna. You can see RRU on the top of the tower near the antenna. We have baseband unit below the tower or maybe in some room. So this RRU is a proprietary hardware. The interface between RRU and the baseband are the proprietary interfaces. The baseband is a proprietary hardware and proprietary software. It means, what does it mean? If you have a remote unit of Nokia, then you can't use baseband of Ericsson, right? You can't use baseband of Ericsson. So these are the proprietary hardware. I will use this word a lot in this session, proprietary, because it is a base concept of ORAN. Okay. Then we have this CRAN. Some people call it centralized RAN and some people call it cloud RAN, but I'm talking about the centralized RAN. So in a CRAN architecture, the base station is split up. The RAR stays at the site, you can see, while the BBUs are aggregated into a centralized off, right? So it is sometimes called as a BBU hotel as well. So it is centralized controller to process calculation digitally, right? So this concept break the 1:1 connection between RRUs and the BBU, and it will virtualize the heavy loaded baseband calculation, and it will bring key function to the central office, which is much closer to our RF engineers and all kind of engineers. So it will convenient for telecom to manage. So by aggregating all the BBUs, telecoms are better organized their computing resources, so they can reduce the cost on the maintenance of 5G network. So this is all about basics of a traditional network. And before moving to the next slide, I request everybody, please answer these questions in the comment box, and it will be very helpful to this channel. So is this video useful to you and the topic of next video you want to watch, right? So let's talk about virtual RAN, right? So in the past, you can see maybe in the 94 or in the years before, we have different kind of devices like radio or a tape recorder, right? We can have radio or a tape recorder. We have a video camera. We have a CD player, calculator, right? But now with the help of network function virtualization, we have a phone, and in the phone, with the help of applications, we can use camera, we can use radio, we can use CD, we can use calculator. All kind of things can be done with the help of network function virtualization, right? To understand virtualization, first of all, we have to understand CORDS. What is CORDS? CORDS is commercial off the shelves. So it is software term for software products that are already made and available for the purchase. What happens in the CORDS? The BBU, right? So BBU gets replaced by CORD server rather than being a proprietary BBU hardware. So we can understand this with the help of one analogy. So now in the past, you have to buy a radio if you want to listen to FM or AM radio. So previously, you need to buy a radio, right? So you have to buy a range of physical radio antenna, and then you tune it, and then you listen to your favorite station, okay? But now you can listen to radio or FM by just simple application, right? You do not need to buy a radio. You can just have the phone and then install the software, and you can enjoy the benefit of functionality technology, right? So if you don't need it, you can just delete it. So same in virtual RAN, you do not need to buy the baseband unit. Just buy the CORD server, and then you can just configure it for the functionality of baseband function, and then you want to implement in your network, okay? So, but the issue with the virtual RAN is that RRU is still proprietary, BBU is still proprietary. The interface between these two are still proprietary, right? So you can't connect different vendors of RRU with two different vendors of BBU. So this is COTS, and but very significant for VRAN, and eventually it will be very significant for the ORAN. But right now, RRU is proprietary, BBU is proprietary, and the interface between RRU and BBU is still proprietary, right? So you can see here you have various equipments like CDN, accelerator, BRS. Even I do not know what are these instruments, some of them. So each vendors have their own proprietary hardware and software. There are many boxes in our network, so they will consume lots of power and space, and these are difficult to upgrade and replace. And it is now replaced by COTS, commercial off the shelf hardware, right? So this allows operators to have a standard hardware at a much lower cost due to economy of scale. So instead of hardware specialists dedicated to each function, now they are generic hardware specialists. And different vendors can now focus on software rather than hardware. So their focus became more flexible and streamlined. So you must be thinking if virtualization is so good, then why it was not possible before? So there are some reasons why virtualization was difficult before. So you can see here, very high throughput is needed before, very stringent latency and timing requirements in case of 5G, right? In 5G, we have very high throughput requirement and very stringent latency and timing requirements and heavy signal processing, right? And limited benefit due to architectural limitation. But nowadays, it's possible to have virtualized RAN because we have many things available, right? Nowadays, we have increased CPU capacity, right? Then we have this hyper threading. You don't need to have details of these terms, just one liner or two liner. So like hyper threading is a technology that enables a single processor to handle multiple tasks simultaneously. So it will produce a lots of good performance. Then you have this NUMA, some call it NUMA, which is non-uniform memory access, right? So it divides the memory into multiple memory nodes, which are local to one or more CPUs. Then we have this DPDK, which is data plane development kit, and it consists of libraries. And the main purpose is to accelerate the packet processing, right? And then we have this FPGA. You may have heard of this term a lot of time. So FPGA is field programmable gate arrays, and these are integrated circuits often sold off the shelf, and they are referred to as a field programmable because they provide customers the ability to reconfigure the hardware. So even after the manufacturing process, we can configure them to meet the specific use case requirements. Then we have this GPUs, which is graphic processing unit, and it is also helping improvement of performance. And then we have new RAN architecture, right? So you know that our 5G is based on various things like SDN, NFV, cloud structure, or you can say cloud architecture, right? So various things are there in case of 5G. That's why now virtualization is possible, and that's why before virtualization was not possible, right? As I said about the codes, so this is codes, and in the codes you can see that previously our approach is like fragmented, and we propose one hardware. So if we made a hardware for MME, that physical thing can be used only for MME. We can't use it as for like SGSN or Node B or anything else, right? And we have to go for physical installation per application. We have to do the hardware development a lot, right? We have to invest a lot in the hardware development. But nowadays, with the help of codes of the commercial of the cell, it allows vendors to get standardized hardware server. The main aim is to reduce the cost, right? And vendors can now focus on the software instead of hardware. And with the help of competition, it will improve our R&D, and it will help in reducing the cost, right? And it will help in automatic orchestration and the remote installation, right? So again, what is virtual RAN? So in the virtual RAN, this BPU, this baseband, is replaced by the core server, commercial of the cell. So you just have a baseband unit, and you don't have to change the hardware. Just by replacing the software, you can improve its capabilities and the efficiency, right? But the thing is that even now, if you use the baseband of Ericsson, you have to use RRU of the Ericsson, right? If you use the baseband of Nokia, you have to use the RRU of Nokia. If you use the baseband of Huawei, even then you have to use the RRU of Huawei, right? So this is not an open RAN, right? So virtual RAN is not equal to open RAN. With the virtual RAN, the proprietary radio hardware remain as it is. Here, the BBU gets replaced by the CORDS server rather than being a proprietary BBU hardware. So the software run on the BBU is virtualized to run on the CORDS server, but the proprietary interfaces between radio and the CORDS based BBU remain as they are. So though RAN functions are virtualized on a CORDS server, the interfaces between BBU and RRU are not still open. So any software vendor can't work with RRU unless the interfaces are open, right? So we have discussed earlier, VRAN consists of vendor A and vendor A software running on the CORDS BBU. So an operator can't put vendor B software on the same CORDS BBU unless the interfaces to the vendor A radio is open. So VRAN can still vendor lock-in, right? So these are the few challenges we have already discussed, like increasing in throughput and capacity requirement. That can be done with the help of split RAN. And then we have this monolithic hardware and software. That problem can be solved by virtual RAN. But now in the next slide, we'll talk about open RAN. So nowadays we want a mix of RAN resources in different services needs. And that problem can be solved with the help of ORAN, right? We'll discuss that ORAN in next few slides. So this is all about virtual RAN, right? Let's talk about ORAN in next slides. And before going to ORAN, if you have any question, please let me know in the chat box, and then we can move to the open RAN. Okay. So can you write please yes in the chat box if you are following what I'm saying till now? Yeah. Before going to CORDS, first of all, we have to understand two terms. One is GPP and one is SPP. So GPP is the general purpose processor, right? So what does it mean by general purpose processor? So suppose I buy a machine, right? I buy a machine. Then this machine can work as a MME. This can work as a AMF. This can work as a SGS, and anything it can work, right? Just upgrade the software and it can work for anything, right? So this is called the general purpose processor, and it has various companies like Intel 86. Then you have this ARM, right, which is advanced RISC machine. And what is RISC? RISC, you know it, that is reduced instruction set computing. Then you have this MIPS, right, million instructions per second. So with the help of these things, you can use the GPP, and it has various advantages, like due to large volumes, economy of scale is achievable, costs are lower, right, and faster pace of innovation. And then you have this SPP, which was used in the traditional network, right? So if one box is MME, then it will always be used as a MME. It can't be used as MF, AMF, UPF, or any other thing, right? So these are the basic difference between SPP and GPP. I will use this term a lot in the session, which is GPP, general purpose process. So now the question comes again, why Open RAN, right? So suppose you buy a baseband, right, of Ericsson, right? Baseband of Ericsson. Baseband can be anything like 6630, 6651, or 6648, right? Then you have to buy RRU of Ericsson only, right? It can be low power like 4410, 4420, or it can be for band 14 maybe 2203, or high power like 4402 or 4415, right? And then you have one OSS also, right? So all these things you have to buy from Ericsson. You can't do like this, that baseband is of Nokia, RRU of Ericsson, OSS of Huawei. So you can't do this at this point of time. So, but nowadays operator wants lots of flexibility, right? They don't want that anybody has monopoly, right? So they want that baseband should be of Nokia, RRU maybe of some other company, OSS should be of other company. So in addition to that, like ORAN is virtualized and intelligent, right? We want to make that baseband and RRU and OSS should be this is the term used by ORAN a lot, interoperable, right? So interoperability should be very important, right? That baseband RRU should be connected with any interface. RRU can be connected with OSS with open interface, right? That's why we need OpenRAN. So why again OpenRAN? So as I said, most of the capex required to build a wireless network is related to the RAN segment. It is reaching 60 to 80% of the total network cost. So any reduction in the RAN equipment cost will significantly help the wireless operators. So as operators are struggling to cope with two challenges. They have two challenges. One is, that increasing mobile traffic, right? And what is the second channel? Second challenge is that they have declining revenues, right? Right. So ORAN will be helpful. So as you know, in traditional RAN deployments, the software and interfaces remain either proprietary or closed by the individual vendor. So they are often tied to a hardware by the same vendor. So meaning operators can't put vendor B software on a BBU from a vendor A. Meaning we can't connect a radio from vendor A to a BBU hardware and software from vendor B. So any software upgrade are tied into the installed base. So if an operator wants to do a vendor A swap, they need to rip all of it, right? So from vendor A radio to the vendor A BBU. They can't replace just one component in the legacy RAN components. So this creates a vendor lock-in because the general consensus is that RAN is 60% of CapEx and OpEx. So OpenRAN helps significantly reduce RAN cost, and reducing RAN cost can significantly impact mobile operators. They can cut down their CapEx and the OpEx, right? So this is the vision of OpenRAN. So the cords remain same as in the VRAN, but now this RRU is replaced by cords hardware as well. And you can see here one term called SDR, which is software defined radio, right? So it can be purchased from any ODM. ODM is original design manufacturer. OEM is original equipment manufacturer, and then hardware vendor. The thing you have to notice here is that the interface between RRUs and the baseband is also open, right? So you can put here RRU of Nokia, you can put baseband of Ericsson, and you can connect these two with the help of this open interface. As I said earlier, any vendor software can work on this hardware. So this is the beauty of OpenRAN, that you don't have to be dependent only on Nokia, only on Ericsson, or on Huawei. If you think that RRU of Nokia is better than Ericsson, then you can use RRU of Nokia. If you use baseband of Ericsson is better than Nokia, then you can use baseband of Ericsson. So this way you can use COP. So it will be easier and cheaper to keep radio from vendor A on the tower installed. So no one has to climb and replace it. Then keep the cords based BBU at the bottom of the tower. Just simply upgrade the software from vendor A to software from vendor B remotely without going to a site. So this is exactly what OpenRAN enables: the mixing and matching of software and the hardware, right? Without the need for replace and the rip, right? So this allows to move from costly and proprietary solutions to the cord based and open software based one, right? So therefore it will create a broader vendor supply chain, right? So these are the basic difference between ORAN and the VRAN. So VRAN uses a virtualized environment instead of dedicated hardware, but the interfaces are still closed. You can see the interfaces are still closed. And OpenRAN, where software and hardware are open source, they are according to the open interfaces and standards, right? So using VRAN can run baseband functions on a cord server, right? Commercial off the shelf server, but the interfaces are still closed. But in ORAN, interfaces are also. So VRAN is very cost effective, and because you don't have to build custom hardwares and you can develop and run the softwares on the cloud. But so that provides a lower barrier to entering the RAN market. But ORAN is one step ahead. as even the interfaces are open in case of ORAN. So this white box is very important for ORAN. So white box is similar to the CORDS. So white box is like the software enabled OpenRAN, right? So it means that baseband units, radio units, and RRUs can be assembled from any vendor, and it will be managed by the OpenRAN software. So what is the main motive? So main motive is to have interoperable RAN. So this way, the underlying hardware can stay on the site. And when a mobile decide to do a swap, the only thing that gets replaced is what they want to replace is software. They will never have to replace the hardware because we are using a white box hardware, right? So it will be very easy to replace, right? So again, this is the vRAN and this is the OpenRAN. In the OpenRAN, the interfaces is also open in addition to the RRU and the baseband. So any vendor software can work on any open RRU, right? So OpenRAN is the disaggregation of hardware and the software, right? And the BBU is same as in the case of vRAN, a CORD server, a vendor-based proprietary software with the virtualized functions, right? So a mobile operator can virtualize and disaggregate their RAN, but unless the interfaces between the components are open, the RAN is not truly open. Right? So let's talk about some functional split. And before going to functional split, any question, guys? Please let me know if you have any question. Okay, no question. So let's move to the radio access network. So as we have discussed that in the radio access network or in the wireless network, we have three main components. One is UE, one is RAN, and one is core net, right? And the RAN is one of the most important part, and it is nearest to the subscribers, and you can see it all around, maybe on the roads, maybe on the mountain, seaside, in the malls, everywhere, right? And it creates seamless coverage and the mobility, right? And RAN is everywhere, right? So this we have discussed. So now we have to discuss some of the layers which are very important for the, we have to understand this before understanding the split, why split is happening. So these are the 7 layers. These are the open system interconnection model, OSI model. You don't have to go in details, but we are concerned about at this moment only 3 layers. One is network layer, one is data link layer, and one is physical layer. And if you know the mnemonics of this OSI, so people just learn by any mnemonics, but I have learned this by like people mean like physical layer, desperately means data link layer, need means network layer, 2 means transport layer, S means session layer, P means presentation layer, and 7 means application layer, right? So people desperately need to see Pamela Anderson, right? Okay. So RAN and the OSI layers. So let's map the RAN in the OSI layer here. So we have 3 main components, right? One is UE, one is RRU, and the third one is core network, or you can say backhaul through BBU and the core network, right? And so this is the antenna system. It can be active antenna or the passive antenna, right? So if you go for the RF part, the RRU, the remote radio unit, okay? So this is where the physical layer can be seen. So here you will see the RF conversion, okay? So modulation and demodulation is happening here. Analog to digital conversion, digital to analog conversion will be happening here. Then we have this BBU, right? So the BBU performs a lots of tasks, okay? So BBU holds various protocols like RRC, PDCP, RLC, MAC, and physical layer. So these are the protocols under BBU. So RRC, or the radio resource control protocol, is responsible for broadcasting, paging, connection management, mobility functions, reporting function, all these things, right? So typical example can be like when somebody is calling you, the network needs to page the network. So it uses the RRC protocol, okay? So a typical example can be when somebody calls you. Then you have this PDCP. Anybody knows the full form of PDCP? Can you write in the chat box if you know what is PDCP full form? Nobody knows the full form of PDCP? Great. Okay. Thank you. So most of the people have given the right answer. So PDCP is packet data convergence protocol. Okay. So it is responsible for IP header, and security and various other functions like ciphering, integration, and all kind of these things, right? And then we have this MAC layer, which is medium access control. So if you are familiar with carrier aggregation, right? So this is where carrier aggregation happens. So carrier aggregation happens in the MAC layer, and other things happens is like HARQ, which is hybrid RQ, channel mapping, packet scheduling, all these things happens here. Then we have this physical layer, and physical layer, all the main functions are happening like coding, decoding, modulations, demodulations, and resource element, and IFFT and the FFT, right? Inverse Fourier transform and Fourier transform, right? So this is the illustration of RAN and the OSI layer mapping. Okay. Then we have this RU, CU, and DU splits. So why we are studying this now? Because when 5G will be deployed, or when right now 5G is deploying, we are using what we call RU, CU, and DU split. Okay. So what is this split concept? So remember the basic architecture of 4G or traditional network. So you have the you have the core network, right? You have the baseband unit, and you have the radio unit. Okay. So the baseband unit is connected to the BBU. So baseband unit connected to the core with the help of backhaul, and RU is connected to the BBU with the help of this front haul. But under the 3GPP approach, which is TR 38.801, they introduce what we call as network split, or RU, CU, and DU split. So the BBU functionality, the baseband functionality, is now separated into two, which is CU, which is the centralized unit, and DU, which is the distributed unit, right? So by splitting this function across multiple units, 5G networks can be deployed in a more flexible and scalable manner. I will use this term a lot. So please remember why we need everything on this session, because we need everything should be flexible and scalable, right? These two terms are very important. And ultimate aim is to have a efficient and cost effective network, right? So this is what we call the RU, CU, and the DU splits, right? So it is cloud optimized architecture. Okay. So now after splitting, we are splitting the physical components of the baseband unit. We are splitting the baseband unit into CU and the DU, right? So after splitting the baseband, we have to split the protocols also, right? So remember, I have shown this slide. Remember, in BBU we have various protocols like RRC, PDCP, RLC, MAC, and physical layer. RF in the RRU. Okay. So now what will happen if the BBU will be separated into two, into centralized unit and a distributed unit? So what will happen if we separate the BBU to CU and DU? The protocol will also be divided, or you can say distributed, right? That's why we have to learn the functional split, right? So as I said earlier, that in case of 4G, we have one RRH and baseband unit is intact. And then we have this core. But now in case of 5G, this baseband unit is divided into two components. One is DU and one is CU. And the interface between DU and CU is called mid-haul. And interface between DU and antenna is called front haul. And CU and core is called backhaul, right? You have to remember. So front haul, backhaul, you have to learn one more thing, which is mid-haul. So connection between DU and CU is called the mid-haul. So let's talk about little bit again the functionality of what you called RU, DU, CU, and core network. So in the traditional network, we have three terms only. One is radio unit, one is baseband unit, and the core network. But in the 5G or in the present network, we have various things like radio unit, DU, CU, and core network. So first is the radio unit. So radio unit is the thing that handles DFP. What is DFP? Digital front end, and it also handles parts of the physical layer, right? Then you have this DU, which is the distributed unit, and it sits closer to the remote unit, and it runs various layers like RLC layer, MAC layers, and the parts of the physical layer, depending on the functional split. We'll talk about functional split in next few slides. And its operation is controlled by CU, which is the centralized unit, and it runs layers like RRC and the PDCP layers. And DU is connected to CU. If it is a control plane, then it will be like we call it F1C interface. If it is connected for user plane, then we call it F1U, F1 user plane, right? So main function of CU are like a transfer of user data, mobility control, session management, etc. So CU controls the operation of several DUs. So one CU can be connected with several DUs, right? DU1, DU2, and so on, right? So CU allows load balancing between different DUs. That is why in most cases, the DU will be co-located with RU on site to conduct all intense functions like FFT, IFFT, and so it will, so that we can have low latency. As you know that in 5G, one of the main thing is this, what is called edge computing. If physical layers are near the site or near the user, only then edge computing can be possible, right? So that's why we need the split between DU and the CU, right? So the actual split between DU and RU may be different depending on the specific use case, but there are various purposes like I have discussed. So what's the purpose of separating DU from RU? So we have to reduce cost, right? So DU will be very intelligent. We'll talk about what is the meaning of intelligent in next few slides, but DU is intelligent. Earlier, we have to make RU intelligent, but now you have to make DU intelligent. It is based on AI, ML, cloud computing, and various other things. So less cost for RU. Then ability to look at RU at once. So it will help in comp, which is called coordinated multi-point, load balancing, etc. So as a processing is done in DU, resources can be pooled, resulting in the pooling gains, right? So the split architecture enables a 5G network to utilize different distributions of protocol stacks between CU and the DU. And it will depend on many factors like customer requirements, transport availability, mid-haul availability, and the network design. So if you have never seen the RU, CU, and DU, so just give you an idea. So it will look like this. So radio unit will look like this, centralized unit will look like this, and DU will look something like this. So previously, RAN architecture in like 2G, 3G, or 4G were based on the monolithic building block. And when we split the G node B into CU and DU, it will bring lots of flexibility and the scalability, and it will help us to reduce the cost, right? So this will be possible only if the hardware and software components are interoperable. And this will be possible only if hardware and software components can be mixed and matched from different vendors. So again, what makes any split architecture open? So a mobile operator can deploy ORAN only if the interfaces between RU, DU, and CU are open, right? So RAN functional splits will bring cost saving if interfaces are open. And then it has many other advantages like we can have load management we can have efficient load management, real-time performance optimization, and QoS, right? Gaming, video, all these functions can be possible only if G node be split into GU and the DU, right? So some functions can be in CU and some functions can be DU. So where latency is the most important, so those layers can be near the site, but where we need the non-real-time functions, that can be near the centralized unit. Okay, so we have many splits options available right now, right? So previously this one is 1 BBU, right? So now we are introducing the functional split options, right? So there is a possibility that in CU you can see the RRC layer or the PDCP layer or the high RLC layer or the low RLC. It depends on how the vendor or the operator wants to have the split, where they do want to split. Okay, so if you want to implement option 2, right, then the PDCP and the RRC protocol will be located in the CU. The high RLC, low RLC, high MAC, low MAC, and the high physical will be in the DU. Okay, so an RF and low physical will be in the RU, right? So you can see also that layer functions, layer 2 function and the layer 3 functions below, right? So if you look at some details in the diagrams like this, so BBU previously this one, okay. So now we have divided into CU, which is central unit, and the DU, which is the distributed unit, right? And the CU is further divided into two planes. One is user plane and one is control plane, right? User plane and the control plane. And then the DU is now equipped with various layers like RLC layer, MAC layer, and the high physical layer, right? So this is how the disaggregation happens, meaning we are splitting the component, the hardware component, and also the protocol inside the component. So why this is important? Why do we need to separate this one? Remember, we have different use cases in 5G. Like if you know little bit of 5G, so you may know what is MBB, right? You know URLL. Then third one is MMTC. You know EMBB is enhanced mobile broadband. URLLC is ultra reliable low latency communication. MMTC is massive machine type communication. So these use cases require different architecture structure. Okay, so especially for example in the URLLC where there is need for low latency communication. So how do we do? If your core network or baseband unit is located 10 kilometers away from you, right? So even if the signal travels at the speed of light, there is still some delay that is noticeable. Then URLLC can't be achieved if there is some distance between RU and the baseband unit. So in order for us to provide low latency, we need to move some part of the network near to the users, right? So these low physical layer and RF layer should be near to the users, or you can say near to the site. That's why disaggregating the network now. So we have different use cases and application needed. That is why we need a split architecture, right? And as I said that we have three interfaces. One is backhaul, one is mid haul, and one is front haul. So between DU and RRU, this is called front haul. Between DU and CU, that is called mid haul, and between CU and core, that is called the back haul. Okay, again, front haul, mid haul, and back haul. So between RU and DU is called front haul. Between DU and CU is called mid haul, and between CU and core network, that is called back haul, right? So between CU and core network, we call it back haul, right? So you can see here, these are the latency requirements for each interconnection. So what is the maximum latency and what is the maximum distance allowed? So you can see that CU and DU, right? They can be 20 to 40 kilometers apart, right? But the DU and CU can be 1 to 20 kilometers apart. So it's possible that distributed unit is located in one building and your remote unit can be located in other buildings. So it's not necessary that RU and DU should be on the premises. So there may be some distance between RU and DU. Okay. So why we need function splits? As I said earlier, that we have flexible hardware implementation. It will improve latency. It will have better load management, and we have split architecture between CU and D. So how to split and why do we need to have a split? So these are the three factors for the RAN splitting. So there is need to support specific quality of service per offered services, right? So as I mentioned before, we have different use cases like low latency. So someone asked that edge computing, right? Let me go to last slide. So the thing is that, let me explain this. Suppose we have this BB, right? We have this BBU and we have this RE, right? Suppose there is a distance of around 10 kilometer between these two nodes, right? So even if the signal travels by the speed of light, right, which is 3 into 10 power 6, I think, meter per second, even then there is some delay of reaching signals to a mobile station or edge computing, right? So that's why, and in BBU all the layers were there, as we discussed earlier, RLC layer, MAC layer, PDCP layer, all layers are there, right? But now some of the layers are in the DU. Some of the layers are in the DU, and DU in most cases are near to RU, right? So if there is no delay between RU and there is no delay between DU and RRU, then it's possible that UE can get signal fast, or any other thing like uh, vehicle to everything, or anything which needs edge computing. That's why we are dividing BBU into DU and CU, so that some of the functionality of BBU is near the site, right? So that's why edge computing can possible with the help of separation of DU and CU. Okay, Akshay, please write yes in the chat box if I, okay, thank you. Okay, so again, why we are here. So as I mentioned before, we have different use cases like low latency for URLLC, high throughput for EMBB, and the real and non-real time applications, right? So second is there is also a specific need for specific user density and low demand for given geographical area. So there are areas where there are lots of users, and there are areas where we have few users. So there is specific support needed on these different kinds of applications. Then we have this available transport with different performance levels. So as you know, transmission network or the transport is very expensive. So we need to optimize how we will use our transport network to further address some applications, right? So how can we have different splits? So now for OpenRAN, the split is recommended is that split 7. Okay. So this split 7 is recommended for OpenRAN. And for applications like 2G and 3G, so if you're doing splitting, it is recommended that split 8 is the for 2G and the 3G, right? So why it's possible? Because 2G, 3G were not as complicated. Hardware is not that as complicated as case of 4G and 5G. So if the functionalities are simple, only then you can have simple circuit or microchips like in 2G and 3G inside the RRU. That's why in the 4G and 5G, split 7 is good option, but for earlier or traditional network, split 8 is the good option. Okay, so there are various splits possible: split 8, split 7, 6, 5, and 3, right? So again, this is the open 7 or 7.2, which is used for OpenRAN. So this split is used for OpenRAN. So option 7 split architecture is where DU hand. So somebody asked me that what is the meaning of high layer and low layer, right? So you can see that we have one physical layer, right? And one physical layer may have many functions, right? It can be modulation, demodulation, coding, decoding, FFT, IFT, right? So some functions are real time and some functions may not be real time. So now we are divided physical layer into two parts. One is low physical layer and one is high physical layer. So some parts which are real time that are near to the sites like IFFT, FFT, and these kind of functions, right? But some functions which are not required on the site that can be put in the BBU or in the DU or in the combination of DU and CU. That can be FEC, forward, error correction, modulation, demodulation, all these things, right? So this ideal option for the RAN deployment for the OpenRAN, right? Its main motto is to reduce the cost and improve the functionality, right? So again, you can see here, so we have divided physical layer into two layers. One is physical high and one is physical low. So physical low has various functions like you can see here, analog beamforming, analog conversion, digital conversion, FFT, IFFT, digital beamforming. But physical high has various other functions like these, right? All these functions, right? So again, we have divided G node B into two things. One is CU and one is open DU. And then we have open RU, right? So that's why we need disaggregation between CU, DU, and RRU, because real-time function should be near the site and non-real time can be put in the BBU or in the central office, which can be easily controlled. So we don't have to go to each site, right? So have I given your answer, Sayed? Okay, thank you. Okay, so before jumping to the next section, I request everyone, please like this video and please subscribe to this channel. It will be very helpful to this channel. So please like this video. Okay, and then we have this benefits and the challenges for the Open RAN. Let's talk about that. So here you can see the share of different RAN vendors. These values may not be current, but it will give you an idea. So you can see that Huawei share in the whole world is around 29%. Huawei share is around 29%. Ericsson share is around 15%, and Nokia 15%. ZTE 11% and Samsung 3%, right? So these may not be current values, but just to give you an idea. So you have main parts in the RAN, which is antenna, which transmit radio signals and receive signals. Then you have radio unit that performs frequency conversion and amplification, and then you have baseband unit that is responsible for processing the signals, right? And many other things, right? So what is the situation today? So situation today is that if you are using radio unit of operator A, then you have to use the baseband unit of operator A only. You can't use baseband unit of operator, right? So it is not happening in our network today. So usually what is happening, if you buy the equipment in the RAN from one vendor, then it's proprietary, because the protocols here will not talk to the protocol implemented by the other vendor. So that is what we call the vendor lock-in, right? So A can't talk with B and B can't talk with A. So this is the situation today without the Open RAN, right? So an inseparable linked setup of proprietary hardware and the software components. Okay, so now the principle of Open RAN goes like this, that we have disaggregated, right? We have disaggregated hardware into two parts, hardware and software. Hardware and software. Then you have RF and UE. So you see here disaggregation of hardware and software. So this is the manifestation of broader technology. So in the IT world, it is already observed many years ago. It already happened in the IT world, separation of hardware and the software. So we separate the hardware, the CU and the DU and the RU. Then we separate also the protocol to each corresponding hardwares. Okay, so for Open RAN, we focus on the disaggregation of RAN components, right? Okay, so Open RAN disaggregated RAN. So Open RAN way is also called the disaggregated RAN. So in our current scenario, we have the core network, we have the traditional RAN, right? So what will happen in the ORAN? There will be use of a, what I use the term, GPP hardware, general purpose processor hardware. The hardware will be open source, and then software will be open source, and interfaces will be open also, so that you can interconnect different equipments from vendor A to vendor B to vendor C, and so on, right? And importantly, there is one more thing called RIC. We'll talk about it later. So RIC is RAN intelligent controller. So this RAN is more intelligent as compared to traditional RAN. So now various functions can be done with the help of AI, ML, cloud computing. So we don't have to do many tasks manually, right? So for a network to become an Open RAN, it has open interfaces between multi-vendor RANs, right? A virtualized RAN software running on a generic hardware. It will increase the flexibility, scalability, and efficiency. Right? So these are the various drivers for Open RAN. You know that we have growing demand for data and everything. Then we have network virtualizations. We have artificial intelligence, machine learning, and big data, and various 5G use cases. Right? Then we have this Open RAN benefits. So these are general benefits like diverse vendor ecosystem, more competition, then more R&D, less cost. Then network can be deployed fast because we don't have to dependent on Nokia or Ericsson. So whatever we like, whoever send us the fast equipment will use that equipment. And third-party software, right? We don't. Then we have automation, right? Then we have this TCO, right? Total cost of ownership, right? So total cost of ownership, because the RU white box radio unit, right? So core server, right? Then we have this CI/CD, which is, if you heard this term, continuous integration, right? And then we have this continuous delivery, right? And we have talked about this white box as well, right? So we have talked about this white box, right? So these are typical hardware. It is based on GPP, low cost radio access networks or white box hardware, right? Using the OpenRAN. And this is the one example from this company called Ranathan. And so this is a white box hardware, a computer hardware such as servers or networking equipment that is assembled using a one off the shelf component instead of a proprietary parts. So we call it white box. So it will be based on ORAN specified open front hall interface, and it used the option split 7.2, which we have discussed in the previous slides. So typical examples can be applications can be ODU, ORU, or front hall gateway, right? And other advantages can be reduced to market, time deployment, less time of deployment, and reduce equipment maintenance costs. So these are the various benefits of OpenRAN. Now, there are major challenges in the telco world, right? Particularly for the operator. And three major challenges is that first is the faster time to market, right? This is the one of the most biggest challenge. So it includes the faster rollout for new features, services, and the capabilities. So like, for example, we have to deploy 5G. So if you want to deploy it faster, we need to have a mechanism or a technology or aware of deployment. We need to be aware of number of subscribers, right? So deploying a new technology will have a significant investment in new networking technologies. So there is a need for flexibility, but there are equipments that are only capable of LTE, only 3G, 2G. So there are equipment that can't be upgraded anymore. So that is a problem. So flexibility is not there. So this is a big problem in a telecom world. So then we have this better performance. So it evolves during the pandemic. So when people start to stay at home and then work from home, right? So there's lots of capacity demand happen. So for operators, they need to expand and improve the system capacities and the better coverage. So if people are staying indoors nowadays, we need to improve the coverage and enhance the capacity. So we know that there is impact on the quality, right? So there is a triangle. You know this triangle very well, right? In telecom, we are dependent on this triangle. So one is, if you write here like this, one is coverage, then we have this capacity, and then we have this what you call quality, right? So these three you are balancing. If you are a radio network design engineer, even though you have a good coverage, if capacity is not enough, then your network design is not good. And if you have good coverage, then you want to increase the capacity. But increasing the capacity means you need to add more frequency in your network, and then it will introduce interference. So quality will suffer. So we have to do something to balance all these things: coverage, capacity, and the quality, and which is one of the major key challenges for us telecom engineers or operators, right? Now there is other dimension on the design, which is cost, right? In addition to this, nowadays fourth term is added, which is cost. So whenever you are designing a network, you just do not need to consider the coverage, the capacity, the quality. Now you need to consider the cost as well. So that is other dimension in the designing process. So lower cost, so cut in energy consumption, equipment cost must be lower, and reduce the capex and opex. So we know that capex is capital expenditure. We know that opex is operational expenditure. So if you build a new site, you need to buy new equipment. Okay. So if you buy a new equipment, then that cost is considered capex. So if you build a network, you want the services of RF engineers, optimization engineers, drive test engineers. So that is also comes under the capex. Now, once the site is already up, okay, then you need maintenance, okay, power cost, cost of electricity, cost of gasoline, that goes to the opex, operational cost, right? So when you are trying to compute the feasibility of a cell site or a network in a certain area, you have to see a payback period. So this is a simple formula of the payback period, which is cost of investment divided by average annual cost. So that's why building a cell site takes a lots of strategy, good strategy, and careful planning. That's why many operators are considering to lower their capex and lower their opex. Okay, so OpenRAN promises to lower these two, capex and the OpEx. Okay. So as I said, there are various challenges in deploying OpenRAN. So it is not it is not all benefits. You can see below the issues ORAN is facing in terms of percentage. So you can see here 40% issues related to multi-vendor operability, right? So multi-vendor operability, and we have issues 40%. Performance and robustness issues are 18%, and then new security issues are 14%, and these are some issues related to OpenRAN, right? So let's talk about OpenRAN main challenges. So the common concern regarding the OpenRAN is the ability to match performance of a proprietary hardware platform, right? So lab trials and light developments are going on for this, and they are moving in the right direction for the OpenRAN. So they are doing it. Next is fault management. Okay, so when something goes wrong in the network, we have to isolate which component has a problem. So in case of OpenRAN, it may be a little complex because Nokia has to work with Ericsson has to work with Samsung, and so on, right? So it may be difficult, but slowly, and they are improving this problem. And then, of course, network optimization. So to fully realize the benefits of OpenRAN and to manage its complexity, operators must invest in various things like cloud management technologies, extreme automation, including orchestration and zero touch provisioning, right? Then we have this understanding OpenRAN ecosystem. So of course, it is a new movement, OpenRAN, right? It is a new movement, new equipments, new protocols, new interfaces, new architectures. So we need to understand the OpenRAN ecosystem, especially for us engineers. One of the biggest enhancement to OpenRAN is the end of vendor lockdown age, right? So you are familiar with the existing vendors right now, but there are lots of players coming in. So there is need to learn those equipment, right? So different new vendors are appearing to supply hardware and software for each element and the network. Then there is a RAN intelligent controller also, right, Rick? So it's important that everybody and everyone involved is aware of all the new hardware and software that currently exist, as well as all the providers. Okay. So for this issue, several initiatives are born to help companies understand and begin this journey, right? And also for new team profiles. Okay. So in OpenRAN, lines between the worlds of telecom and the world of IT are blurred, as I read in my WhatsApp message also. So now this implies that roles of and responsibilities of OpenRAN and ITs are merging, right? So if you're a telecom engineer, then you have to study various things like virtualization, AI, ML, SDN, cloud computing, all these things. And IT guys have to learn telecom things like propagations, antenna concepts, link budget, etc. Right? So there is some merging of these two industries, and we have to become hybrid, right? So teleco has to learn IT, and IT has to learn teleco. So that when it becomes fully blown, you should be prepared, right? So when jobs comes, you should be fully prepared, right? So other main issue in the OpenRAN is integration. So many people will ask that who will do the integration between OpenRAN? Nokia will do the integration, Ericsson, Samsung, who will do the integration? So in the network, there are various components and vendors, right? We have various things like application, OSS, BSS vendors, core network vendors, and many different vendors for transport, RAN, small cell vendors, RRH antennas. So there are lots of vendors, right? So who will do the integration is also a big challenge, right? So before jumping to the next slide, I request everybody, please answer these questions in the comment box. It will be very helpful to me to prepare next video. So please write what is the topic of next video you want to watch, and is this video useful to you? Okay. So next topic we have to talk about is OpenRAN groups and initiatives. So the question someone asked that, do you think it will make the operation more complicated? Yes, I feel that it will make the operation more complicated initially, right? Initially, everything is complicated. Even when a child starts walking, that is also a complication, right? So, but slowly, he used to it. When you start driving, you have to take care of accelerator, brake. But after a few months or few years, now when you start the car, even you don't think where are the brakes, where are the accelerator. Yes. So initially it may be complicated, but slowly with more R&D, with more research, with more efficiency, it will be easy. So after a few years, you will be used to ORAN. You will forget traditional network, right? So in the future, you will be used to that RRU maybe of Ericsson, baseband of Huawei or Samsung, right? So yes, initially everything is complicated, but in future it will be resolved. So future is OpenRAN. So please start learning OpenRAN. Please start learning Python. Please start learning little bit of AL and ML if you want to survive in this difficult telecom market, because nowadays IT people are taking all of our jobs. So if you want to survive, if you want to grow, please learn new things like, as I said, OpenRAN, Python or AL, ML, and little bit of cloud computing. Okay, friends, let's move to the next topic, which is OpenRAN groups and the initiative. Okay, Akshay, let's move. Thank you. Okay, so OpenRAN groups and initiatives. So let's start with the telecom infra project or TIP, right? So we'll discuss about various things here. We'll discuss about TIP, which is we'll talk about TIP, which is telecom infra project. Then we have ORAN alliance. Then we have other key OpenRAN groups. So in that we have three parts. One is ORAN software community. Then we have small cell forum, and then we have this OpenRAN policy coalition. So first part is here, what you call is the telecom infra project or TIP. So telecom infra project is one of the two industry groups heading the OpenRAN initiative. So it was founded in 2016 by Facebook or Meta right now. So as an engineering focused collaborative technique for designing and implementing global telecom network infrastructure with the objective of allowing universal access to the internet. Okay, so these are also involved in the initiative of supporting the OpenRAN, right? And its board of director comprised of founders from technology and the telecom industry, right? So it is founded by Facebook or Meta, right? So if you go to their website, which is telecominfraproject.com, you will get all the details, right? So TIP is more about deployment and execution. So they encourage plug fest, right? They encourage plug fest. So plug fest means better equipment. We have DU and CU. So you bring your CU, you bring your DU, and then let's try to interconnect. Let's try to put it together. So if they will work, they will pass interoperability testing. So TIP is initiative to define and build various solutions for 2G, 3G, 4G, 5G RAN solution, right? And it is based on general purpose vendor neutral hardware, open interfaces, and the software. So this is TIP, telecom infra project, right? Then we have second group, which is ORAN alliance. So after 2 years, ORAN was formed in Feb 2018 with the goal of promoting OpenRAN and the intelligent RAN. So this is the second group or the organization driving the RAN movement. So the organization that merged to form the ORAN alliance are the China Mobile and mainly other Chinese vendors, and the XRAN entity like Docomo and the American vendors. And founding operators alliance is the AT&T, China Mobile, DT, NTT, Docomo, and the Orange, right? So this is the ORAN alliance, combination of CRAN alliance and the XRAN alliance. So these are very important because when you go to some ORAN interview, they will definitely ask these kind of questions. Do you know about TIP? Do you know about ORAN alliance? So these terms are very important if you want to move to the ORAN companies, right? So we have discussed about TIP. We have discussed about ORAN alliance. Now we have to discuss about other key OpenRAN groups, right? So first one is OpenRAN software community, right? So this is the collaboration between ORAN alliance and the Linux Foundation. Its mission is to support the creation of software for the radio access network. As I said earlier, that the telecom industry is experiencing a great transformation, and 5G is expected to radically change how we live, how we work, how we play, everything, right? So this means it's critical to make network infrastructure commercially available as quickly as possible, right? And the motive is to ensure business success for the operators, right? So the ORAN software community is focused on aligning with the OpenRAN, open architecture and the specifications, right? What is the main focus? The main focus is to achieve the solution that can be utilized for the industry deployment. So ORAN software community is the open source community under the Linux Foundation, and it is sponsored by ORAN Alliance, right? So it will enable the development of open source software, and it will enable modular, open, intelligent, efficient, and agile disaggregated radio access networks, right? Then we have this small cell forum. So this has created its own ecosystem of OpenRAN with small cells in the mind. So recently they have focused heavily on creating the open interfaces. So in 2020, they expanded the set of specification they released the previous year. So they want to enable small cells to be constructed piece by piece using components from different vendors. The purpose is to easily address the diverse mixture of 5G use cases, right? Then we have this other key OpenRAN group. So here you can see Open Network Foundation and the SDRAN, right? Software defined RAN. So this is also part of OpenRAN, and it is used components of mobile RAN space complementing ORAN focus on architecture interface, right? So this is also a kind of OpenRAN group, right? So you have seen various terminology in the market like OpenRAN with a space, OpenRAN without a space, O-RAN, small ORAN. So there is small difference between all these three terms. So let's see the meaning of each term. So OpenRAN, right? So first one is open space RAN. So this is the movement in the wireless telecommunication. The main purpose here is to disaggregate hardware and the software and to create open interfaces between them. Then second one is open RAN. So open without space RAN. So this could mean two different things. Number one, it could refer to the TIP group, which is Telecom Infra Project Group. And number two, open RAN can be used as a hashtag on social media sites like Twitter, LinkedIn, Facebook, etc. Right? And the third one is O-RAN or ORAN, right? So, ORAN with hyphen refers to ORAN Alliance, right? And so ORAN Alliance publishes new RAN specification, right? It releases open software for RAN. So it supports its members in integration and testing of their implementation, right? So ORAN can be also used to refer OpenRAN movement, but O-RAN or O-RAN always means ORAN Alliance, right? So hashtag ORAN, they can also use on social media like in Facebook, LinkedIn, right, to refer to the ORAN Alliance or the OpenRAN movement. Okay. As I said earlier that we require shift in mobile networks due to increase in amount of traffic. Traffic is increased because of various reasons like better devices, newer applications, faster connections, and even cheaper data plans, right? And as you know that 3GPP does an excellent job of separating the user and the control plane. Also, various options are available in 5G nowadays, like option 2, option 3x, option 5, option 7, and so many of, right? But the organization like ORAN plays an important role to bring the industry together. Their main job is to create more software-based, virtualized, flexible, intelligent, and energy efficient network, right? So these goals can be achieved by evolving RAN to a higher level of openness and intelligence, right? So openness, you know that DU, CU, and RU are open. In addition to that, interfaces also between them should be open. But OpenRAN also call for a more intelligence in the network. It can be done by collecting information from various virtualized elements with the help of, you know, that NFV, SDN, cloud computing, right? Various other things, right? So artificial intelligence and machine learning can then be applied to the information collected with the help of NFV, SDN, cloud computing, and so on. So openness and intelligence, these are the two main pillars of the OpenRAN. right? So it may be confusing as the role of these two industries. One is TIP and one is the OpenRAN. So OpenRAN Alliance, first one is OpenRAN Alliance. So this is related to, like in 3GPP, right? We have various things, like in 3GPP, we have various codes, right? Like there's like 38.212 is for channel coding. So the same thing, ORAN Alliance put some rules, put some protocols, right? It develops and enforces standards. It wants to ensure that equipment for multi-vendor should be interoperate with each other. It provides some kind of front haul specification and all kinds of this, right? But the tip is related to deployment and testing, right? So tip enables the open ecosystem. It ensures different vendors, software and hardware equipment works with each other. So it is responsible for productization of use cases, and it facilitates trials, field testing, and the deployment, right? So you can say that OpenRAN movement is possible only because of TIP. OpenRAN is successful only after the success of TIP, right? So TIP brings various groups together, right? So this is the main difference between TIP and the ORAN. So TIP is all about deployment, but ORAN is all about specification, rules, right? Then we have discussed various difference between OpenRAN. So OpenRAN is disaggregation of CU and DU, and ORAN is related to ORAN Alliance. And then we have talked about that VRAN is all about the virtual RAN, right? So these are the ORAN. Yeah, I will share my email ID in next few slides. So please wait. So these are the various contributors and academic contributors for OpenRAN. So if you want to move to OpenRAN, you can apply in any of these companies. So Altius, they don't have many openings, but yes. So here and there, they have some openings. So be open and go to their website and check what kind of job description they have and try to learn the things they want in their job site. So main companies are like this: Altustar, ORAN, Armdex, Mavenir, Nokia, Parallel Wireless, Cisco, Intel, and ZT, right? And there are various membership companies like these. So these are the various companies which can, right? Then we have talked about deployments and trials. So let's go to last part, which is deployments and trials, right? So deployment scenarios for the OpenRAN. So since the system would be open, the equipment, the hardware, the software and interfaces are open, not like a proprietary hardware. So what are the different deployment scenarios? So we can implement, of course, a typical network deployment for coverage extension and the site densification. Of course, for us RF engineers and the optimization engineers, we see a deep challenge when we're deploying OpenRAN in the existing network. Suppose we have a traditional network, right? Suppose we have a traditional network, right? So this is our traditional network. Maybe you call it traditional network A, right? And suppose you want to implement OpenRAN, right? Maybe OpenRAN. So maybe the neighbor definition. So if you're familiar with the neighbor definition, you see that the rules between A and A for the neighbor definition will be same, but the neighbor definition may be different with the OpenRAN, and they will treat OpenRAN as a different network. So because of different equipments and different protocols, right? So initially it may not be that easy, but slowly it is happening with the few changes in the traditional net. See, as I said earlier, everything is a channel, everything is a challenge when you are doing it the first time. But slowly, with more learning and experience, you become more efficient, right? Then we have deployment in urban and the suburban, right? System replacements and the upgrades. So if you want to change out the equipment, we know that the task of system replacement is very huge, especially for RF engineers and the optimization implementation, right? Like, for example, the system replacement, right? So one network will change the equipment from vendor A to vendor B. So that's a huge task, actually, right? So even though we have to change equipment in a small area, it is still a huge task, okay? From planning to implementation, but we can deploy like that, right? With the help of OpenRAN. Then we have this rural coverage. So if you want to expand coverage, it's better to use OpenRAN, right? In rural, population is not that high, so we can begin installing OpenRAN in the rural area. And now if you have greenfield area, right? Like if you have a greenfield, right? Like in the US, there is a company called Dish Mobile, right? So they are using OpenRAN. So when they deploy the network, since they are greenfield operator, they can deploy immediately with the help of OpenRAN. So they can use any combination of different hardware and software of different vendors. Then you can also support private and neutral host networks, right? So you can deploy OpenRAN, like for example, you have a factory in 5G, right? You want to create a 5G private network. You can have an OpenRAN here, right? You can deploy OpenRAN. So you can use tower sharing, right? So these are the few deployment scenarios for OpenRAN, right? And these are the few deployments and trials going on. So like in AT&T and so on. But I was talking about Dish. So Dish is doing this thing, right? So I'm talking about this. Okay. So before going to the next section, so let's talk about the course. So I have one course with 5G end-to-end training. So if you want to enroll, so you can enroll for this course. And so this is the link to the course. So let me give you the link also. One second. So here is the link to the course, and I will give you one thing more. Okay. So these are the link to the course. So if you want to enroll for this course, you can enroll also. So there are various topics that will be covered like this. These topics will be covered. You can get details on this website also. So all these chapters will be covered. So in addition to that, this is like 14-hour course. So you will get various books also, which are you don't have to pay anything for these books. So you will get various books like 5G physical layer. I have used all these books to make this course. So all the PDF copies of this course you can get from all the PDF copies you can get through this course. So this is the course. So all these books, more than $500 books. So you can get these books through this course also, all these books. So again, you will get very thing like 14 plus hour studies, more than 450 slides, and $500 books, all these things. So the course is of $199, but just for today, I'm making it for like 9.99. So if you want, you can enroll for this complete course. And let me make this to 9.99 at this moment, and so that you can enroll. In the meanwhile, I request everybody, please subscribe to this channel and give me 2 minutes. Let me change it to 9.99, and please subscribe to this channel and please like this video. It will be very helpful to me. So please go to this link, and in the meanwhile, let me change it to 9.99. So please do this. Okay. So I have changed the price to 9.99. If you want, you can enroll for this course, and I hope this course will be very helpful to you. So let's move to the last part of this section of this webinar. And have you subscribed to this channel, guys? Please write yes in the chat box if you have subscribed to this channel. Okay. Thanks for subscribing. So I just need 2 more subscribers to reach the count of 1,000. So please subscribe if possible. Please subscribe to the channel. I need only 2 more to reach 1,000 more if you don't have links. So please subscribe to this channel, and then we can move to next section. Please write yes in the chat box, guys, if you have subscribed, already subscribed. Okay, thank you. Let's move. Oh, wow. Thank you. 1,000 done. Thank you. I have not seen the YouTube, but yes. So, but thanks friends for all the help and making it 1,000. Thanks a lot. Okay. So as I said, the course is of now 9.99. So if you want, you can enroll for this course. And if you don't want, that's fine, because there are many videos available on YouTube also. But do something like learn something new if you want to survive in this difficult telecom world. Okay. So please learn, keep on learning, right? So, but this course is good. I have made this course with, okay. Thanks for posting. Thank you. Okay, so let's move to the last part, and you will get the certificate also. So, okay. So before moving to the last part, so I request everybody, please like this video and please share this video with please share this video with your friends as well, and please subscribe to this channel so that it can reach to as many people as possible. So let's move to let's recall what we have learned, right? Let's talk about that. So first of all, what we have seen. So we have seen the evolution of RAN, right? So we have learned that RAN is a critical component of the wireless communication. It provides coverage and the connectivity to the mobile device. And there are several RAN architecture available today. And each of them have unique strengths and the trade-off. And the choice of RAN architecture will depend on range of factors. It may be dependent on specific use case, network topology, available resources, and the performance requirements. So operators can optimize their network performance, improve efficiency, and deliver high speed, low latency, and higher reliability data, right? And in 5G applications, we have various kinds of applications, right? So in the RAN evolution, first we have seen what we call as the traditional RAN. So we call it the DRAN, or you can say distributed RAN. We call it the traditional RAN. So if you hear something about DRAN, we are referring to the we're referring to the traditional RAN, right? So this is the traditional RAN architecture that has been used for many years for technology like 2G, 3G, and maybe for some cases in LTE as well. So it consists of separate baseband units and the radio unit, which are connected through a dedicated fiber or the copper cables, right? So the cell sites or the basebands or the RRUs are located in the cell site premises, right? So this is the distributed RAN we have discussed about. So here baseband units, radio units are located inside the premises of the cell, right? Premises of the cell site. So we call it the distributed RAN because RAN is at the distributed locations. So that is the traditional network, right? BBU is connected to RRU through a CPRE cable. Then RRU is connected through antenna through a jumper cable, right? So this is the traditional RAN. Then we have this, what we call as the centralized RAN or centralized network. So it emerged in response to need for a more flexible and cost-effective solution. So it uses centralized processing. You need to support a multiple remote radio head, okay, which are connected by a high-speed fiber optic links, okay. This approach can help to reduce cost and improve network efficiency. So what happened here is that baseband unit previously located in the premises of the cell site, it is now located in the central office. So we call it the baseband pool, right? In some technologies, we call it as the baseband hotel as well. So those basebands are pulled together in the central office. So for ease of control and maintenance, okay. So this is also using a fiber optic. You must pair it, connect this RU to the baseband pool, okay. So the BBUs are pulled in the centralized location. The site only has the antennas and the radio unit, but the BBU, RU, and interface are still what you call proprietary. You see it under the control of existing vendors like Ericsson, Nokia, Samsung, etc. Right? Then it became the what we call as virtualized network, right? Virtualized network. So virtualized network builds on the benefits of centralized network. Actually, it is CRAN as well, but it adds the virtualization technology to further improve efficiency and the scalability. So by using software-defined networking and network function virtualization, it creates a virtual network function. So it can be rapidly deployed and scaled as needed. So just imagine if I have to add some capacity or carrier of LT to a traditional network, what I need to do? I have to go to the premises on the cell site, insert the board to activate that carrier. So he needs to go in the outside premise. But what will happen in the centralized network? In case of centralized network, so the engineers do not know to go to the cell site premises. There is a central office where he can upgrade, switch the boards, and then activate the LT. But this time is the virtualized network. So if the operator wants to increase capacity or direct traffic, he can do without physical intervention equipment. You can do by virtualization, by adding command only, then create a new instance of the network. And if that instance is not needed anymore, you can just delete that instance, okay. And then comes the OpenRAN. So the OpenRAN, now we have the core network. Baseband unit is now separated into centralized unit and the distributed unit, right? The GPP hardware means general purpose hardware we have to use, or the COTS hardware. We are using SDN, NFV, and many other technologies, right? So interfaces are open in case of OpenRAN, meaning you can mix and match different vendors to the different vendors of RU to CU to DU, okay? So this is how the OpenRAN is different from the virtualized RAN, okay? So you remove the proprietary equipment. This is how the OpenRAN different from other radio access network, okay? So this is what we have seen, that in traditional RAN we have RAN support and services, but in the OpenRAN everything will be disaggregated into hardware and software, right? Hardware and software, everything is disaggregated, like node integrated, Everything will be disaggregated in the future RAN, right? And we have talked about OpenRAN Alliance also. So OpenRAN Alliance was formed in Feb 2018, and it is formed by the merger of two main companies, which is CRAN Alliance and which is XRAN Alliance. And finally, we came with a new company, which is ORAN Alliance, and its founding members are AT&T, China Mobile, NTT, Docomo, and the Orange. Right? And its vision, you know it that first of all, architecture should be open interfaces, open CUDU, right? We use open white box, CORDS hardware, right? And software should be also open. We don't have to pay anything for the software, right? Artificial intelligence, with the help of that, we can use feature of COM, we can use the load balancing, right? Without intervention of any engineers. Now, at moment, optimization or load balancing is done manually. Maybe in future it will be done by artificial intelligence. Then everything should be interoperable. Nokia should work with Samsung, Samsung should work with Ericsson, Ericsson should work with Huawei. Everything should be interoperable, right? So they just give like it's growing, right? First is A, B, C, D, right? They give some name, but they want to grow it like that: A, B, C, D, E, F, right? So this is some name. Also, we talked about TIP that was formed in 2016, which is Telecom Infra Project, right? Which is Telecom Infra Project, and its main function is the deploying and the testing, right? And we're talking about various other companies as well. So ORAN is based on 3GPP standards, right? Then we have this SD-RAN, ORAN software community, and TIP, right? So all these things we have discussed in our session. So we have discussed difference between traditional and OpenRAN as well, right? So in the OpenRAN, everything is software defined, right? It is based on technology like network function virtualization, SDN, software defined network. It is based on white box, right? But in the traditional network, everything is proprietary, right? Vendor lock-ins and all these things, right? So traditional network has various issues related to scalability, right? And so basically OpenRAN is more software based, but traditional RAN is more hardware based, right? It is not as flexible as OpenRAN, right? So previously RAN architecture are very monolithic, right? A component which is used for one purpose, it is used for that purpose only. But the splitting the G node B into CU and DU would bring lots of flexibility, right? Flexible hardware and software will reduce the cost, right? And then all the devices should be interoperable, right? So like in traditional RAN, everything is closed, right? No open interfaces, no interoperability. But at the first level of disaggregation, we are divided into DU and CU. But now in case of OpenRAN, we have used the term Open DU, ODU, Open CU, OCU, ORU, right? So these are things you can use in case of OpenRAN, and it will help to automate our functions related to load management, QoS, all these things, right? So these are some of the functions of some of the benefits of the OpenRAN, right? Then we are talking about various interfaces also, right? So the key concept of OpenRAN is opening the protocols and interfaces between various building blocks like RRU, BBU, CU, DU, right? And RAN is disaggregated into three main components. One is RU, one is DU, and one is CU, right? So RU is where the radio frequency signals are transmitted, right? Here radio signals are transmitted, received, amplified, and digitized, right? And RU is located near or integrated into the antenna. As you know the terms like AIR, right? Antenna equipment radio, right? Or you may have heard the term AAS, automatic antenna system, right? So these things, advanced antenna system, all these things are available nowadays. So then you have this DU, right? DU is distributed unit that is located at or near the RU, right? And then you have CU. CU is located near the core or at a centralized premises, right? And front haul is between RU and DU, and mid haul is between DU and CU. So these are small terms you should remember thoroughly, because you should know this. And if you want to go to OpenRAN or any other, if you want to grow in telecom, you should know these terms by heart. And then we have seen that RAN evolution as well, right? So we have seen that earlier BBU and RU at the premises of the site. Then BBU moved to a centralized office, and where all those layers are layered like physical, MAC, and RRC. But now layers are also splitted. So some layers go to CU and some protocols goes to DU, right? Then we have talked about RAN functional splits also, right? There are various options available like split 8, split 2, split 7.2 and all these options. But for ORAN, we are using this option, which is split 7.2. Here we are dividing physical layer into physical high and physical low. So some functions of physical layer will go to physical high and some function go to physical low. So real-time function will go to physical low and non-real-time function will go to physical high. Okay, so this slide we have discussed that physical high functions will be scrambling, modulations, layer mapping, pre-coding, and the RE, resource element mapping. But physical low mapping, which is real-time functions like DAC, ADC, like digital to analog conversion, analog to digital conversion, beamforming, IFFT, CP, cyclic prefix added, and pre-coding. All these things function will be at the physical low. Why? Because these are the real-time function. And real-time functions, so latency is dependent on the real-time function. If these are far from the site or far from the user, then low latency may not be achieved. And in 5G, one of the main component is edge computing, right? Main component is edge computing, and which is dependent on the low latency, right? And there's various benefits as we have discussed earlier. The first one is like interoperability, right? So 5G defines common interfaces and protocols. It allows for the integration of hardware and software components from multiple vendors. It will foster interoperability. It will avoid vendor lock-in, right? So this promotes healthy competition, innovation, and the cost efficiency in the RAN network. Then you have this vendor neutrality. So traditional RAN solutions often involve tightly integrated hardware and software provided by a single vendor. So it makes it challenging for operators to switch or introduce new technologies. They have to pay a lots of money and there is lots of disruption. So ORAN aims to decouple hardware and software, right? So it will enable operators to mix and match products, right? Then we have the innovation and the ecosystem expansion. So by opening up RAN interfaces, ORAN encourages collaboration between different vendors. It will encourage small vendors also to enter the market. So it will foster innovation, diversity, and competition. Then you have this cost reduction, right? So it will reduce the cost because now you have lots of competition. So it will reduce cost, right? Then you have this network flexibility, right? So network will be flexible because now you are not dependent on any other company. So ORAN represents the paradigm shift in the telecom industry, and it will promote openness, interoperability, and vendor neutrality, innovation, and the cost efficiency. So it aims to create a more flexible, competitive, and diverse ecosystem that benefits network operators, equipment vendors, and the end user alike. So this is the definition of OpenRAN. We have discussed that RAN infrastructure that supports ORAN aligned specifications combined with increasing RAN virtualization, data-driven intelligence will allow carriers to reduce complexity, innovate more quickly, and significantly reduce deployment and the operational costs, right? Like we have discussed, reduced CapEx and reduced OpEx, right? And these are the few codes from various people. So these are the codes. So again, this is our OpenRAN. So this is an industry movement that develops disaggregated and the interoperable radio access network solutions, leveraging general purpose processors and hardware, software defined technologies, and open interfaces based on the industrial standard, right? So this is the open. So friends, I know some people are struggling with lots of jobs in telecom because there are less jobs in telecom. But the thing is that I have read here somewhere that even companies are struggling to get people with good skills, with high skills. I think there are enough jobs in the market if you have good skills. So please learn some new things because if you remain in that RAN part, right, it will be very difficult to survive. RAN plus software knowledge will make you like a skilled employer. skilled employee, right? So please learn new things. And I feel that winning has a combination of passion plus skill plus experience and target. I feel with this course, you will at least get these skills, right? So I request everybody to enroll for this course. And I think you will get good learning with this course. And I think 9.99 is nothing amount. So please enroll for this course. And this is all about me. So if you want to know more about me, you can go at the LinkedIn profile. So linkedin.com/in Gaurav dash Goyal dash 5G. So you can learn about me and you can connect with me. So all these things you can. So these are the few things we have learned in this session. So these are the things. Again, guys, thanks a lot for joining this session. I hope this session is useful to you and you have learned something new. And I hope this year will bring lots of success and happiness to you and your families. So happy new year once again, guys. Okay, thank you. So see you next time with the new webinar. Again, thanks a lot for giving me your precious time. Thank you.